Hi everyone. Today I brought a very nice question and this question has appeared in JEE Adv 2025 and the question is based on electrostatics. Before I describe the question and give the solution, let me first mention what are the things that we should know in order to solve this question. Okay? So the first thing we should know is what is called Gauss law. So what does Gauss law say? If you have a closed surface, let's say a cuboid, then the flux of electric field through the closed surface given by the symbol phi is equal to the total charge inside the closed surface divided by epsilon naught. So this Q here is the total charge, the net charge inside the closed surface. Okay, inside the closed surface. Now sometimes in the question they will mention there is a dielectric medium within the closed surface. Then will Gauss law change? Some students think maybe we have to write here dielectric constant. Well, actually students, the answer is whether there is dielectric medium or no dielectric medium, Gauss law remains the same. The total flux through a closed surface is always equal to total charge inside divided by epsilon naught. However, you know that if there is a dielectric medium, then some charges will be induced on the surface of the dielectric medium, isn't it? So while calculating the total charge inside the closed surface, you will have to include the charge which is given, like in this case this Q charge was already given inside the closed surface, plus some charge which may be induced on the surface of the dielectric. So this is charge induced on the surface of the dielectric, and this is the charge given to some body which is inside the closed surface. For example, this could be the charge on a capacitor, plate of capacitor. Let me give you more clarity on this. So let's say we have two parallel plates of a capacitor which is connected to a battery, and this plate is grounded. So whenever one of the plate is grounded, we know the outer charge will be 0, right? And here the charge will be plus Q, and here the charge will be minus Q. And you know that Q is equals to C into V, where C is the capacitance of the capacitor and V is the applied voltage, right? Now let me take a closed surface, cubical closed surface, something like this. So please understand this is a cuboid. The other sides are inside the board, so it is not visible. Okay, so it is a cuboid, three-dimensional. You are only seeing the cross section. Now you can see what is the charge inside this closed surface, Q. So the flux through this will be equals to Q by epsilon naught. Okay, so here Q is basically the charge given to this plate due to the connection of this battery. Now let me introduce here a dielectric medium. So this is a dielectric medium. Then you know that because there is a dielectric medium and there are molecules inside, and this plus Q and this minus Q will create electric field from plus Q to minus Q, right? And because of this electric field, the plus charges in the molecule will be slightly displaced this side, and the negative charge will be displaced this side. We have already studied that. So that's why this side will acquire a net positive charge, and this side will acquire a net negative charge. Okay, so these charges are what are called the induced charges. So this is Q induced, minus Q induced, and this is plus Q induced. So now when you apply Gauss law, you have to still use it the same way. So the electric flux now in the presence of dielectric will be also the total charge inside divided by epsilon naught. But now if you notice carefully, the flux through this closed surface is the charge Q which was given to this plate, also the charge which is induced in the dielectric, right? Minus Q induced. So total will be Q minus Q induced divided by epsilon naught. So this is how we should use Gauss law if there is a dielectric. Okay. Now we should know that the formula for Q induced is equals to Q, the given charge, into 1 minus 1 by K, where K is the dielectric constant. This formula, if you don't know, I will try to prove at the end. Okay, try to see the video till the last if you don't know this formula. So now we will substitute this Q induced in this equation. So the electric flux through the closed surface when there is dielectric will be equals to this Q by epsilon naught will be one term minus Q induced by epsilon naught. But Q induced is this, right? So substitute Q by epsilon naught 1 minus 1 by K. You can see this minus Q by epsilon naught into 1 will cancel with this. So you will get minus minus plus Q by K epsilon naught. So this is what in some textbooks you will find that Gauss law is given this way. That the electric flux through a closed surface when there is a dielectric should be Q by K epsilon naught. But understand that way if you write, then this Q is not the total charge inside the closed surface. In that case, this Q is only the charge given. Or sometimes it is also called the free charge. Basically, this Q represents all the other charges besides the induced charge. Okay. Now the second part is actually easy, but sometimes students get confused on how to find charge on a part of a cylindrical surface. So imagine you have a cylindrical conductor, okay, and I have given some charge. Then you know on a conductor the charge given will stay on the outer surface, isn't it? Now I will be able to show you only here and here, but it is actually on the surface. So please try to imagine, okay, it is this side also, right? The back side and here front side. So like this charge will be distributed everywhere on the surface. Let's say the total charge given is Q. Now if I ask you, I want to know charge on half part of the cylinder. So I want to know charge on this half part of the cylinder. Then obviously what will be that? Q by T, charge on half part of the cylinder. Obviously, right? But how can we derive this? Well, we can write this as the total charge given by the total area into the area of the half part. So now what is the total area of the cylindrical surface? 2 pi r into L, where r is the, let's say, radius and L is the length. And what will be area of this half part of the surface? It will be half of 2 pi r into L, isn't it? Now if I cancel this r pi, this 2, then you will get Q by 2 pi into pi. Now this is a better way to think of calculating the charge on a part of a cylinder. This formula is a better way to think than this formula. Because anyways the length will get cancelled, the radius is getting cancelled. So how to think of this formula? Well, this charge Q, if you see from the top, is distributed in 360 degree. But we want charge in only this half, which is distributed in 180 degree. So the total charge given divided by the angle in which it is distributed when you see from the top. So this is the angle in which the total charge is distributed. 360 degree means 2 pi radian. Then multiply with the angle in which you want to know the charge. So this is a better way to think. So this is again a cylindrical surface, but I want to know charge on only this part of the surface. And that angle is theta radian, let's say. Okay, so I hope you understood. This is the cylindrical surface. I want to know charge on only this part. So when I see from here how much angle it subtends, okay, that angle is, let's say, theta. Then the charge on only this part will be obviously total charge by the angle in which it spreads when you see from the top view into the angle for which we want to know the charge, and that angle here is theta. So this way, if you try to remember how to find charge on a cylindrical surface, it will be more efficient and more faster. Okay. Now let me describe the question which was asked in the exam. So they gave a conducting cylinder whose length was given as L and the radius was given as R. Okay. And a charge Q was given to this cylinder. Q. Now they surrounded this cylinder with another coaxial cylinder of same length, and the radius of that cylinder was given √2r. Now it is mentioned that the outer cylinder is grounded, which is also conductor, remember. So once you ground the outer cylinder, the charge on the outer surface must be 0. Why? Why it should be 0? Well, if you ground this will be at 0 volt, and you know infinity is also at 0 volt. So if this is at 0 volt, outside infinity is also at 0 volt, then there cannot be any electric field outside, because electric field is from higher potential to lower potential. So this is also 0 volt, infinity is also at 0 volt, so no electric field outside. So if there is no electric field outside, you cannot have on the outer surface any charge. Otherwise these charges will create some electric field, right? So for that reason the charge on the outer surface must be 0 if that conductor is grounded. Within the conductor you can have charges, that is not a problem, because you know of electrostatic shielding, right? So this conducting surface will shield the outside from the charges which are inside. So inside charges cannot create any net electric field outside. Clear? Now they also mentioned that in the space between the cylinder, they have put a dielectric medium whose dielectric constant is 5. Okay, that you remember. Now what we have to calculate? Well, we have to calculate electric flux. And if they mention electric flux, they have to mention the surface through which we have to find the flux. The surface given is a plane surface. Okay, something like this. And that comes from that side. This is behind, okay, and it is this surface. So through this surface we have to find the electric flux. Let me do it more properly, because these two sides I should show parallel, then only the 3D feeling will come, right? So we have to find electric flux through this surface, and they have told this surface is at a distance of, there is a small change in the question, students. This radius of the outer cylinder is actually 2r, and radius of the inner cylinder is √2r, and they are asking flux through this plane surface which is at a distance r from the center, from the axis, we can say. This is the axis of the cylinder, right? Now when you see this way, you may get a little confused. So what JEE Adv has done is it has also given you a view from the top, meaning the cross-sectional view. So if you see from the top, you will see this inner cylinder as a circle of radius √2r, remember, and the outer cylinder you will see as a circle of radius 2r, and this plane surface you will see as a line. This is the plane surface, and this distance is given as Okay, so try to remember the radius. I will remove it. Too many things if I write, you may get confused. So radius of the cylinder you remember. So this is the plane surface. Now how to find flux through this plane surface? Well, whenever they ask something like this, we have to think of using some kind of symmetry and all. Okay, otherwise if you think of finding electric field and then integrating, it will take time. So you remember, right? We do questions like, if there is a charge q and I want flux through this plane surface. If this side is a and this charge is at a distance a by 2, then how do we find flux through this plane surface? We don't find electric field here and then we don't integrate, right? The simpler way is to construct a cuboid and then apply Gauss law to this cuboid and then find flux through this plane surface, isn't it? Flux through this cuboid will be charge inside by epsilon naught, and then there are 6 surfaces, right? And therefore we want only flux through one surface. So flux through this surface, the given surface, will be q by 6 epsilon naught. We have to divide by 6 because there are 6 surfaces, isn't it? So something like that we need to do. Okay, we need to think. So what we will do is we will create an identical surface here like this. Let me draw it solid line only, and then from back side it will come like this, and then this will be your closed surface, isn't it? So this will be a closed cuboid kind of surface. So that I will show you here. Okay, so at same distance r, I will create another surface like this. Now how to find flux through this cuboid or flux through this cuboid when you see from the top? Well, this is a closed surface, so we can use Gauss law. So we need to know charge inside. Now how to find the charge inside this closed surface? Well, you remember, right? Charge q was given to this cylinder, and since outer cylinder was grounded, the outer surface will have 0 charge, and due to induction this will have inner surface of this outer cylinder will have minus q charge. That we study, right, in basic JEE course. If you want to know how this happens is you draw a Gaussian surface through this metal. Through this metal inside this material of the metal, you draw one Gaussian surface. Now since it is inside the metal where electric field is 0, so flux through that surface should be 0. If flux through that surface is 0, charge inside should be 0. So if this has q, this side must have minus q, right? Okay. Now they told there is dielectric, but we will not worry about that because we will use this formula for Gauss law. Phi is equal to charge given divided by k epsilon naught. So if you use this formula for Gauss law, you don't need to worry about induced charges in the dielectric, right? Okay. Now what is the charge within the closed surface? Look carefully. This should be only the charges which are inside, okay? The charge given without worrying about the charge induced in the dielectric. Now we want charge here which is inside, we want charge here which is inside, we want charge here which is inside, and we want charge here which is inside. So how to find? Well, I told you, right, how to find charge on one part of a cylinder. You need to know the angle subtended by the circle when you see from the top. So we need to know this angle. So how to find that angle? Well, let me redraw this circle here for you for clarity. This circle, and this is the dotted line. This plane is here, remember? This is the plane, the red color plane. This distance is given r, and the radius of this was given how much? Root 2r. So from there we can easily find this angle. So sine theta will be opposite by hypotenuse will be r by root 2r. So theta will be 45 degree, which is pi by 4, isn't it? So if that is pi by 4, this is also pi by 4, same theta. And remember, we want this angle. This angle we want. So if this is 45 and at same distance here we took one more surface, right? So this angle is also 45. So the angle subtended here is 90. So this angle we came to know is 90 degree. It may not look like 90, but after calculating we came to know it is 90 degree. So what will be charge on this part? This is plus, remember, okay, plus charge this is. So Q total charge by total angle when you see from the top is 2 pi into 90. So that will be how much? Q by 4. So this much charge is Q by 4. Now we need to know charge on this part, right? That is negative charge, remember. But we need to know this angle subtended. So again, let me draw the bigger circle. Here one plane, here one plane. This is the center line. And this distance was given R. This is now 2R, right? So this angle, if I say theta dash now, will be what? Sin theta dash will be, opposite is R, hypotenuse is 2R, so 1 by 2. So it will be 30 degree, which is pi by 6. So if this is 30 degree, this is also 30 degree, right? So therefore, this whole angle will be 60 degree. So this whole angle will be 60 degree now. So this will be 60 degree, which is pi by 3. So this is pi by 3. So what will be the charge now? Total charge is minus Q divided by angle subtended by the whole circle is 2 pi into angle subtended by this part is pi by 3. So minus Q by 6. Right? Okay. So now what is the total charge inside this? Forgetting about the induced charges in dielectric, remember, because I have used K here. So the total charge inside will be here minus Q by 6. Here Q by 4. And same thing will be here and here also. So I have to multiply with 2. And here also I have to multiply with 2. Divided by K was given 5 epsilon naught. So the flux will be equal to minus Q by 3 plus Q by 2 divided by 5 epsilon naught. So 1 by 5 epsilon naught into LCM if I take 6. 3 2s are minus 2Q plus 3Q. That will be equal to Q by 30 epsilon naught. Isn't it? Now the flux that we calculated is the electric flux through the cuboid. Now in the cuboid there are 6 surfaces. However, out of 6 surfaces, 4 surfaces will not result in any flux. Why? Look carefully. This back surface is this surface, right? That is outside the conductor, outside the cylinders, where there is no electric field outside. So flux through this surface, which means this back surface, is 0. For same reason, flux through this surface is also 0. Now what about flux through this surface, ABCD? Well, they told the length of this side is same as length of the cylinder. Therefore, this surface is lying on top of the cross section of the cylinder. It is lying on top of it like this. And since we know electric field lines of cylinder inside will be from plus to minus radially outwards when you see from the top. Therefore, these lines of electric field are parallel to this surface ABCD. And since the lines are parallel to the surface, there will be no flux through that surface. So, no flux through this surface, therefore no flux through this bottom surface also. So, the total flux is only through this surface and this surface, which in this diagram means this surface and this surface, right? And since these two surfaces are symmetrically placed, the flux through this surface and this surface must be same. So, if it is phi dash here, it should be phi dash here also. So, the total flux will be 2 times phi dash. And since we want flux through only one of the surface, phi dash, that will be equal to Q by 60 epsilon naught. And that would be the final answer, right? Now, as I promised you, I will try to derive this formula in a simple way. So, if you think of the plates of a capacitor and you give plus Q minus Q charge, electric field in between the plate is sigma by epsilon naught, which is, let me keep it as sigma by epsilon naught. Okay, sigma is Q by A. This Q is the free charge or the charge given to the plates. So, let me write this electric field as E naught because this represents electric field in free space. Now when you put dielectric, there will be some induced charges here, Q minus Q induced, and here plus Q induced, and because of that there will be one more electric field. If E naught was this side, because of these charges there will be one more electric field this side, which I will call EP. P, because this process is also called polarization, this separation of plus Q and minus Q in the dielectric. That separation of charges is also called polarization. So the net electric field now will be E naught minus EP, and is also electric field in free space by dielectric constant, and this is EP. So now E naught is sigma by epsilon naught, and this can be written, this is due to induced charges, so it can be written sigma induced by epsilon naught. So if I cancel epsilon naught, sigma induced will come this side, sigma minus sigma by k, so it will be sigma 1 minus 1 by k. Then this is surface charge density, which can be written as charge induced per unit area, free charge per unit area, 1 minus 1 by k. A gets cancelled and you get this formula, right?